Well, hi, good morning. Thanks so much for joining me in my shop for my first day with this radio. Today is February 4th already. Oh my gosh. So I just finished, if you're watching my videos one after, as I post them, you know I've just finished working on two great big 65-pound monster radios with 30 tubes in them. Communications radios. Two famous ones, in fact. Here's another well-known communications radio, not nearly as big and heavy, but it's heavy. It's heavier than it looks. There's a lot in this radio, I guess. So this has come to me from a buddy. He's left me a note. Let's see the note. Thanks again. Tubes in Hallicrafters tested okay on my tester, but it is just a cheap one. So I don't think there's too much here for us to really be worried about. The radio's in great looking shape. The link is open. A bit of tape there. Looks like it has a phono. It says phone. What is that? Phone. Phone? As in phones. As in headphones? I think that must be headphones. Okay. Well, it's got a hinge on the lid here, so this will be just a pop it open sort of deal. Yeah. Wow. Lucky I didn't find that out the hard way. Pop that guy right open. I've got to raise up my camera here just a sec. Okay. So let's see what we've got here. Speaker looks just perfect. String is in place. Two lights. Lonely resistor up here. Tuning. Oh, tuning. Here we are. Yeah. It's got two spring clips, one here and one over there, kind of grabbing the chassis from the cabinet. I guess that's how they make the cabinet electrically connected, just with those pressure clips. Well, it's not a very complicated looking radio at this point, is it? This must be a 6H6. This would be the detector tube. 6BA6, 6BA6. Another 6BA6. 6C4. This will be the oscillator tube here. And we have 5Y3 rectifier and a 6K6 output tube. 6SC7. Now that's a little bit of an unusual tube. Not sure what it's there for. 2-section capacitor. 3 IF cans. There's all the adjustments here. I can see all the capacitor screws in there. There's adjustment here. So this has a slotted, looks like a large slotted slug. So it looks like you got to have the chassis out, or can we get at it underneath? Maybe they've made it with some holes or something under here. No. Big screw, another big screw here. 3 big screws. What about the front? What's holding the chassis in there? Another whole set of oh, a little nervy thing. Whole set of screw adjustments here. There's something going on here also. With these clips I can see. We gotta get the chassis out. How does it come out? Must be those big screws underneath. What else could it be? Looks like it's awkward to get out too, because this has edges here. I guess you must tip it or something. Tip it out, tip it out. I think I'd rather have it out before I operate it. Oh, hold on a second here. All these controls are mounted right on this panel. So how does this work with all these on the panel? Must pull out the chassis must come out. I got it. I think I got it. The chassis comes out with all this on the front. Take these screws out, and the whole thing comes out the front. I think that's what it must be. Must be the case. So I'm taking this off of here. When I was a kid, I got a hold of an old regular dial phone. Actually, it was a Princess phone, and I wanted to take it apart. I spent a long time finding where they hid the screws on those phones. They're very, very clever for hiding the screws. But I was persistent, and I eventually found it. One of them, you had to take the where the main cord comes out the back of the phone. There's a bit of a stiffener to protect the cord. And push that up fairly hard, and hidden underneath it was one of the screws. I was very, very excited when I got it apart. Putting it back together is another story. That's not true. That's when I began to realize that just because you can't figure something out at first, no reason to not keep trying. Okay, there's probably some screws underneath here at the front. Ooh, something flopping around inside the radio. 3 more here. Yeah, pretty sure. These are not the same screws. Sure, I'm not the first person. So what are these big screws doing? They look like they're going right into the... Yeah, so maybe I haven't got this right. Hey, something's going to come apart. Maybe a Princess phone is going to fall out of this. Hey, most of you don't know what a Princess phone is. That's not true. Chances are you who are watching this video are around my age, so you've lived the same world. This screw's not right at all. Those have to be going into the chassis, so let's get them out. So it's getting towards the end of the winter here, and we have not had much snow in my area, not compared to what historically has fallen or what is possible. Actually had snow around us, but our particular exact location, not a lot. I think I only had my snow blower out 3 times this year. After I reconditioned my old snowblower, big snowblower, left here when I bought this house. The previous owner just left it. And once I started working on it, I know why he left it. It needed a fair bit of work. But boy, they'd never had a snowblower before. What a difference. Shoveling snow is a lot of work. Okay, this thing is definitely coming apart now. These clips are pretty solid. Now, what to do about the speaker wires. So I can see Someone's been at the speaker wires here. This one is not soldered. This one is not soldered. This is tied on. So we're going to just nip this one off too. One wire's not enough anyway. There we go. T2232. Oh. Williams, 21 Bowmore Avenue, Ottawa, 5. I guess maybe Mr. Williams was an owner at one time, maybe the original owner. I don't know who Mr. Williams is. Okay. Now we have it out, we can do a little better inspection underneath. So this tube's got, this is my style, W 45 times 2. This is supposed to be a 6 SC7. 6 SC7. Okay, we have to guess that's a replacement. Oh, this one's got a label on it too. 6BA 678 is, I'm going to guess, is the percentage test result. What are you doing way up there? Come down here. Come down here. I'm trying to watch this from a helicopter. Oh, here's an adjustment I hadn't spotted earlier. That's probably the oscillator. Taking a wild guess. What's underneath? I can flip this guy right upside down. Oh, 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 it's a world of paper capacitors. Wow! Okay, first of all, nice radio to work on. Everything's spread out. And look at the number of capacitors in this thing. Oh my gosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, at least 15, probably 2 more I missed. 15 capacitors, all paper. That's a lot. Lots of room for degradation in there. Many coils. This is kind of reminiscent of my Pi radio that had all these coils in it. Many coils. There's the trimmer capacitors for each coil. I'm looking carefully at all the resistors, looking for any that are darkened or burned in any way. They all look pretty good. So we look up around the power supply area here. We've got, so what this is the new power cord here. The tape just doesn't last. This black electrical tape. Particularly, it has to be put on with a stretch. I think this was put on without stretching it. Good tape, you're stretching out almost 50% of its length before you're applying it. So you're doing like that. This is not quite 50%, but you need to put some stretch in it. Then it grips and it holds itself down. But as all of us know, in the long run, the outer layer peels off and the goo comes out. Now what's all of this? So you can see this capacitor under this fairly high wattage resistor. This one looks like this one runs warm too. They're right in the power supply. This is a high wattage one, is almost certainly the key element in the power supply. There's almost certainly heat here that's been heating up this capacitor. And look at the thing. It is in an ugly state. So that's about the biggest piece of degradation I can spot in here. Do we dare turn them on? Why not? We'll turn them on. I got safe ways of doing it. What about this guy here now? So what we can do here is pretty simple. And I don't know who. Perhaps the current owner who has given me this radio did this. I would say to him, why, if you can solder it here, why couldn't you solder it there? Because look, the insulation is just fraying off this whole thing. Let's fix this right away. So we have a secure wires here. You don't have to worry about tape or anything like that. So I guess, you know, hey, so you saw the tape is just peeling itself off. It could come off to the point where this is exposed. And you have exposed wires under the radio. You don't know about it. Somebody hands you a radio, you don't know what's underneath. You don't know something like this might exist. And, yeah, I'll make a mistake here. Let's leave the tail. Same thing here. So, not good. How is this wire anyway? Just looking right in here. Looks okay. I don't see that it's damaged anywhere. We can carry on with this one. Unpolarized plug going straight switch, basically going to the switch and going to the primary, the transformer. Nowhere else. There's a capacitor to ground right here. So this is an important guy right here. We'll look at him next before we power up the radio. Yeah, so I mentioned, and you may have been watching me work on two great big radios, a Hammerland SP600 and a Collins R390A, two classic radios that I am so fortunate to own. Both of them came in the shop here performing okay. Both of them I found serious defects in them. Hammerland is my own handiwork. my own this is a little tight here. I'm going to change this way. In both cases, you know, without doing a full restoration, which is a big job on those big radios, I got substantial improvements in operation on two radios that I thought were working pretty good already. So the videos I made were a little sloppy because the process of fixing them was very long and drawn out. Solder that right away. Oops. So both those radios I've been using as my standards. I compare other radios against them. Same antenna, that kind of thing. And then I can judge. But now I've realized the performance of those two radios was actually subpar for themselves. Significantly subpar. I'm very excited to go and listen to them. I have them back in their listening spot. They're all wired up. They're ready to go. And it was so late last night I couldn't turn them on and listen to them. So I'm hoping to set up a decent video arrangement where I listen to all these radios, because I don't listen to them here in the shop. I can make some videos of the radios I've fixed being used. You know, I mean, that is the idea, isn't it, in the end? Put this this way. To use these radios. I'm excited too because the solar situation is going to improve tremendously over the next years, like a 4 or 5 year upswing, and then a couple of years at the peak. And during that time, shortwave reception is going to greatly improve. What exactly is out there to be heard? A lot of stuff still. Lots of stuff. And I'm excited about that. I've sort of had a hiatus from serious shortwave listening for the last few years because of conditions. So I focused on improving my antennas. I seem to have done a good job there. I'm using folded dipole antennas made with TV flat wire, old TV twin lead, I think it was once called. These antennas have proven to be very low noise, and that's perfect because we're not in a low noise environment anymore anywhere. Really, really stunning performance, I'm hoping. Okay, so we have the power wire on here. Is there any chance of a short happening here? No. There, that's better. Okay. Now, look at this, is interesting. Using a copper band here instead of a wire. The designers of these radios, I'm sure, become sensitive about lead length on components, and at times they know that they have to keep the lead length really short. Here's the opposite example here. This resistor has a gigantic, it's a gigantic dipole antenna in here. But I guess it's not important. The designers would know that. In other cases, when you look, sometimes they're cramming the connection really close, like this one here. Really close to the capacitor. Now that could be because that's just how much space there was for this capacitor to fit in. But it also could be because they knew this lead had to be kept really short. Yeah, another thing, and shame on me, I ignore most of this most of the time, all these capacitors have bands on them. The band marks the outside foil end of the capacitor. But you take a new capacitors, at least the ones I get, they never show you the outside foil, which you can determine with a simple test, but for the most part I've been ignoring it. Okay, any last things that make me not want to start this guy? Oh yeah, this capacitor. Yeah, we're going to do that one right now. So this capacitor, if it were really leaky, could allow the chassis to supply enough current to your hand when you unfortunately touch it under the right conditions, or maybe I should say wrong conditions. Oh my gosh, how close to a short circuit do you want to get there? Have a look at this. If I can focus the camera here. Focus a little far away, but look at the lead of this capacitor. It's kind of mixed in with the grounded wires coming off the end of this capacitor, but it's not part of it. Yeah, my camera's not doing it justice. Let's just say at a glance, it really looked like a short circuit. And I could make it into one easy enough. Okay, we'll snap this guy out. I think this is the only molded capacitor of this style in the whole thing. I have some belief this was a better capacitor. It's in a position where it can ultimately be basically across the line. Not really. Not really. That's good. What size do you think that is? 0.05? Okay, we're going to test this guy a couple ways. First test, very simple one. Take our super modern tester here. Give him a go. Capacitor shell's in great shape. So 10,000 picofarads, that's a 0.01, isn't it? 10,000 to be 10 nano 0.01. So 0.01 looks like a 0.01. There's probably nothing wrong with this guy. So this test only goes so far though. This is really kind of more for modern equipment. Capacitors aren't being tortured with hundreds of volts like they are in these old radios. So we're going to put 50 volts on this capacitor, DC, and any current leaks through, it will cause this eye to close. Tiny, tiny current, close this eye. Okay, and then I'm going to apply the voltage. Watch the eye. So the eye closed and popped open, it charged the capacitor, and there's no leakage. 150 volts. Oh. Okay, so the eye isn't opening at 150 volts. Let's go back to 50. Wow, okay, that's a little unusual. Usually you can see, you know, if it's going to be like this at 150. So it's a little leaky. Now, you know, how much? What is that, a microamp? 50 microamps? 5 amps? I don't know. It's not 5 amps, I know that, but I don't know. So a little hard to judge how dangerous this might have been. I guess I could plug it in and out. Let's stick my tongue on one wire and then I could report from there. Yeah, my final report. So 0.01, I'll stick a 0.01 in there and a better capacitor, and then we can plug the guy in, turn him on. Okay, got a speaker hooked up on a temporary basis here. So starting up a radio like this, there is a little bit of risk of doing some kind of damage in the radio that, you know, you might shed tears over after, but the risk is actually quite low. In this case, very low, I think. So we are going to put it in here. We're going to be using the dim bulbs. Here, I'm going to put in this fairly small radio, so I'm going to put in a very small light bulb. Just that light bulb. And also control the voltage here. I'm going to turn it down a little bit. So we're going to be sending 100 volts to the light and the radio, and they're going to share the 100 volts to start with. If there's something seriously wrong in the radio, this dim bulb, it won't be dim. It's going to come on full tilt. It may come on fairly bright. Anyway, so we stand by and receive. Band selector, band, broadcast band is A. That's A. CW or AM, we want to listen to AM. Down here, phono. It says phono and it says sensitivity down here. Phono sensitivity. What would that be? Oh, this is a band spread radio. Can you see the pointer is sticking on the back of the glass? Dragging on the back of the glass. Noise limiter off. Here's the volume. So this is volume. And you know, you gotta get right down on the floor to read these words. Why didn't they put them across the top? Volume and off. Tone. You just have a high and a low. I'll leave it on high. Okay, I think that's all the controls. Tune this down around. On this radio there are 2 civil defense markers for an American civil defense system when everybody in the United States was scared that Russia was going to bomb them. And so they had 2 frequencies on every radio, and they marked them with the civil defense mark. This one's at 640, and there happened to be a Canadian radio station right there that I can pick up here. So we're going to go. Not a civil. The whole civil defense thing is gone. You know, years ago when I visited the United States, I was stunned while walking around Washington to see plaques on the wall saying, "Building can protect 20 people," or something like that. So if there was a nuclear attack, you run to one of those buildings. So nothing like that here in Canada. Nothing at all. No, we blissfully ignored all that, and I was never really afraid of a Russian attack. Never really cowered myself ever. And hey, never happened. Okay. Interesting sort of twist on that story is part of the protection from the potential Russian attack was the formation of the distant early warning line way up in northern Canada and in Alaska with extensive radar systems way up north. I'm sure if you're a radio person you know about it. The Hammarlund SP600 radio I was working on just a few days ago came from the DEW line. So I was told, okay, I think we're ready to turn this guy on. So first we're going to check to make sure the on-off switch goes on and off. So we're going to apply dim bulb power. Nothing should have happened. We have 99 volts available here. 99 volts shared between that bulb that you need to keep an eye on and this radio. So I'm going to flip this on. The bulb may go bright for a moment, but just for a moment. A bit of a longer moment. So 38 volts, which is a ridiculously restricted voltage to the radio here. It's too much of a restriction. So we can compensate a little bit with this. Turn it up. Now 45 volts, still ridiculously low. So I'm going to screw in another light bulb. Turn this guy down a little bit. This will boost it up, that's for sure. This guy's drawing a little more power than I would have imagined. 88, 89 volts. So that's enough that we should hear something. If it's got something to tell us, volume up. It take a long time for tubes to warm up with the reduced voltage here. That's full volume. Double check my speaker connections. Yep. So we're at 79 volts, no action. And now, oh, here it comes. It's still too low. I'd rather have it up at least around 90. Let's take this up. I'm watching the voltage here on this. 87. Oh, and now I've remembered something I wanted to say to all my viewers. So in the YouTube video making process, the YouTube process tells you when the standard definition version of your video is ready for public posting, and then sometime later the high definition version becomes ready. For the last month, none of my videos have indicated that the high definition version has ever become ready. Yet I checked them on YouTube and the high definition version is there. My experience, it varies from computer, TV, all that kind of stuff, is YouTube will try to serve up a lower definition version of the video than what they might have available. In my case, I'm always uploading high definition videos. You should be watching them in high definition. You may not. You may be watching them in standard definition or even worse. So there's a little gear on the screen on YouTube. Click on the gear and you'll find not only can you change the quality of the image, you can change the speed of the video. Think about that for a minute. Okay, let's tune around. What do we got here? This is a slight hum, not much. Slight hum. What are we using for an antenna? Hey, that's a really good question. Well, what is this? I just sort of thought it had a rod antenna in it, but now that I look, it ain't no rod antenna. It's using nothing for an antenna. So here's the antenna terminals. We need an antenna. Okay, I do have one. Somewhere I do have one. Here we are. What I'm talking about is the antenna lead wire. I have the feeling that my antenna may not be switched on down here. Let's find out. So this is going to an outdoor antenna maybe. Now there's a link here. The link is open. So if you have the kind of antenna I've got, it's not a single wire. It's a folded dipole. The antenna has two leads coming from it. They want to do this in the radio, as opposed to this. Okay, so that's a single wire. This is the 2-wire. There's different inputs for those. 2-wire. Ooh, she's ready to go. What should I do here? Volume down. Volume down? Yeah. So I think if you have a single wire antenna, you close the link. If you have the kind of antenna I've got, you leave the link open and you connect to these 2 screws. Okay. Let's just listen for a second. Okay, sounds okay. Spin it around. Spin some of it around. Okay. Are the lights not on? The lights are both on, but 640. So the radio is still operating on reduced voltage of 89. Okay, so we're going to give it the full juice here. Let me just turn this guy down a little bit. Full whack. Now he's getting, well, not full yet. 100 and, let's give it 100 and what? 110. There we are, 115. Now we're cooking. 117 volts, right on. That's just normal stuff. This is 590. A little off. $680. The French station. Reading here. Doesn't want to do the French station. Okay, so that's a bit of a judgment on the. You know what? I gotta go make sure the antenna's turned on before we assume things. Okay, I go throw the switch. Okay, switch already thrown. Let's go for shortwave band. Band B. That's pretty low, frequency wise. It's very quiet. A little more reception down here, quiet up at this end. Next band, band C. Ooh, what was that? I think I just passed something powerful.
Joshua, is ready. Well, we're out of time again. I wish we could keep going on and going on.
Strikes me the AVC may not be working in the radio. He's safe. Yahweh. Yahweh. That's what he said. So that, I had to turn this up, way up. That suggests no AVC in this radio. Same thing again. Roughly a megahertz away. Powerful signal being picked up roughly a megahertz away. Image. This suggests the local oscillator is operating below the target frequency. Yeah, just about exactly a megahertz. So that's 455 doubled, so it's 910. That's what that would really be. Okay, so the radio's working. That's the main thing we're doing right now. Not how well is it working. Is it working? Volume full. She's stone quiet here. Stone quiet. That's something new I just invented. Picked up WWV at 20 megahertz with one of those big military receivers. It's just silent here, and this is no more to get. Could be weak tubes. The owner said he tested the tubes. They come around 15 megahertz here. Just dead. Dead. Oh, oh. Band spread. Oh, that's much better. So the band spread is working with a logging scale. So that way you'd have a piece of paper and a pencil with you. You tune this in, you'd call this, well, it depends how you want to do it, but you could call that 3, and then you could say 0.30, or write a note. So you dial this up to 3, and then you hunt down 30. This is not going to work very well, because if you're a little off up here, you'd be way off down here. Well, maybe not way off. It's nice, much nicer tuning. With a dial like this, you're never going to know what frequency you're on. Exactly. This is not that kind of radio. Not like the 2 military radios I had. But it's working. Okay, now next band. Oh my gosh, 48 to 54, the 6 meter ham band there. Set main tuning. Set main tuning with a big arrow. What's that mean? I don't know. Okay, we'll go up there. What in heaven's name are we ever going to hear up here? Set main tuning. Maybe we do this. Doesn't make sense. A little dirt in the capacitor, maybe. Oh, you're supposed to set it on that. There's 3 vertical squares here. They're all lined up vertically, and the same thing here, all lined up vertically. It's possible. This is not scale. Look, I have another radio up here. This is not a good one to look at, but I'll show it to you. So here's another band spread radio. Here. This guy. It's a regular dial and then the band spread. Now, this dial is calibrated in frequency. Let me just change the band selector. See, it's calibrated in frequency. But this dial you must set to, in this case, you set it there to 80. There's another spot here, 160. I never noticed before. I don't know how that works. You set this dial here, 80. Now this dial is calibrated. You can read it directly. That's the idea. That's the idea of that radio. Gone set. Another similar radio to this one in terms of scale, quality, and that's probably a little bit better. In fact, a little bit of a better radio. So we're not going to hear anything up here. I can't imagine. What would we hear up here? In fact, this isn't even moving on this dial at all. This dial. Oh, you know what? Set name tuning. Okay, we'll assume set it all the way. That's where it wants to go. And then this probably becomes accurate on the band spread. So that would be 50 megahertz. 48. What's up there though? Hey, what's going on here? Aha, so I've encountered some traction problems, but I'm not the first one to encounter them. You can see on the turning spindle here, someone has put tape on in an attempt to increase the friction in here. The string feels like it's been rubberized, but you can see the problem with it. It's got no tension. Where's his tension coming from? So there's got to be a spring in the deal somewhere. Is it just one string here? Or is it? No, of course there's two strings because there's two tunings. Help this one along. Oh, look at that. I didn't really realize how this was even working. There's the main tuning capacitor, and then look at the single blade one over there. Look at that. Huh. Never seen that before. And this has just completely lost its tension. Did it come off a pulley? I don't think so. Oh, it's terrible. Looks like a string job. The other string looks good though. Let's check the other string here. So the other string does not feel rubberized. This one has something on it. And the tension is tension's great. Why did the tension go in this one? The string's been tied here. So I think the string broke and somebody tied it. Maybe they shortened it. They shortened it up. They may have reduced the number of turns here to get more string. Okay, now I see that challenge coming. And we can get around it right now. So we don't know what's going on with the higher band. Who wants to listen to it anyway with a radio like this? Nobody. So I think the next step is we'll go through and retest all the tubes in the radio. Even though the owner has tested them in his own, I guess he has a emissions tester. We'll test the tubes. The radio's largely working, so I think it's going to be capacitors and alignment. There's a lot of capacitors to do. And then the alignment is what's going to bring this radio up to life. And I bet you it's a nice radio to listen around, not to identify what frequency you're on, but just for tuning around quick, because you can get from one side of the dial to the other pretty quick. Zooming around. Okay, that's good for now.